College Algebra, section 5.3. This is how you graph rational functions. And instead of doing yours, I'm going to do some that are like the ones we have to do. So the 5 steps begin by, does it reduce? If it reduces, a factor in the numerator will cancel a factor in the denominator. Now this x cannot cancel one of the x's down here because these are not just x in the denominator. This is x minus 1, this is x plus 2. It would need an x minus 1 or an x plus 2 in the numerator, or just an x in the denominator. So no, and that means really no holes in this graph. So they say use the 7 steps. I'm saying use the 5 steps that I've got. Vertical asymptotes. That's where the denominator is 0. So x equals a 1 would make that 0. And x equals a negative 2 would make that 0. So we can begin our graph by putting in, let's see, x equals 1, vertical asymptote, and x equals a negative 2. I'm going to put those in a different color. Maybe I'll use yellow for that. So here's the vertical asymptote. Okay. Go back to green for these steps. So step 3, non-vertical asymptotes. What is the degree of the numerator? Well, it's just 1, x to the first. The denominator, x times x, will give you an x squared plus some other stuff, but it'll give you an x squared at the most. And then you can say, what's the degree of the numerator? 1. The degree of the denominator, 2. Since the degree of the numerator is less than the degree of the denominator, it is a horizontal at y equals 0. That's my alarm, but that's okay. So we have a yellow asymptote. At y equals 0. Now, since this is right on the x-axis, I'm going to put it just above so I can see it. So don't have yours, I guess, disappear for me when I see those. They should be just above, just below, especially if they're right on the axis then. Okay, step 4. Now it will never cross the vertical asymptotes, but it could cross the horizontal one. So you set 0 equal to this x over x minus 1 times x plus 2. Multiply both sides by that x minus 1, x plus 2. You still get 0, but they cancel on the right side and you just get x. So hold it, x equals 0. So the answer is yes, at x equals 0. So it crosses at 0. It crosses the horizontal asymptote at 0. Okay, step 5. Now we look at positive infinity, negative infinity, and between to see what's happening. Well, positive infinity, I'm going to put in a 10. So I've got 10 over, this is 9 times 12. And what is 9 times 12? Let me do that over here. 9 times 12, see 18, 9, 10. 108. So 10 over 108, and you compare that with, let me get rid of this part here. You compare that with our horizontal asymptote, 0. This is 108, a little bit greater than 0. So now I'll be able to say it's above. And I'll be able to graph this over here at 10. It's above. It doesn't cross, so it does something like that. What about Negative infinity. Well, let's put in a negative 10 while it's here. So it's a negative 10 in the numerator, and a negative 10 is a negative 11, and a negative 10 would be a negative 8. So a negative times negative is positive, it's 88. So a negative 10 88ths. Compare that with 0. Well, that's less than. So it's below. So over here at negative 10, we are below the asymptote. And we don't cross, so it does something like this. Between, we can't use 0 because 0 is where it crosses the asymptote. We got to know if it's above or below. So let's use a negative 1. Plug in a negative 1. That's a negative 1 in the numerator. And a negative 1 here is a negative 2 times a negative 1 times 1. So this is really negative 2 over negative 2, or positive 1. So at negative 1, it's positive 1. And that gives you what happens since it's got to cross those two things. And that is your graph. Now, it's always helpful. Your calculator can give you a decent graph for this. But you are better than it is for most of this stuff. So let's see if we can, especially if you've got this older one. For y equals, let me clear out these two. And we've got x divided by, and now we got to put this in parentheses, and then each of these in parentheses, x minus 1. We need the whole denominator in parentheses, and then x plus 2. And then close the parentheses for the denominator. Now, for the window, let's go, usually negative 5 to 5 is good for most of these. Negative 5 to 5, scale of 1. Negative 5 to 5. Oops, negative 5 to 5, scale of 1. And let's then graph it. Now these vertical lines are not, if you've got the newer operating system, it doesn't put it in there. So those vertical lines are not supposed to be there. All you get is this going down, then it starts up here at positive infinity. The reason it draws that line is because it's trying to connect the point down here at negative infinity to the point at positive infinity, and then it's doing this part. So our graph is pretty darn good. In fact, smarter than this TI-83 Plus, because we know these are not visible, they're just dashed imaginary lines. So that's how you do number 8, which is like number 7.